Okay, let's have a look here. First one doesn't look too bad because I think what we have to do here, we'll just change tan into cos, sine over cos. So that'd be sine pi over 6 over cos pi over 6 over 1 minus I sine pi over 6 over cos pi over 6, and then we'll multiply everything by cos. So we get cos pi over 6 plus I sine pi over 6 over cos pi over 6 minus I sine pi over 6. So that's cos pi over 6 plus I sine pi over 6. And a little trick here is we can change this into cos minus pi over 6 because it's even, still the same. And that's plus I sine minus pi over 6. And when you divide complex numbers in polar form, you just add the argument. So that would be cos 2 pi over 6. So that's cos pi over 3 plus I. Sorry, I said add, I meant subtract. When you divide, you subtract the arguments. So it's pi over 6 minus minus pi over 6. Okie dokie. So that is a half. And then root 3 over 2, isn't it? Yeah. Root 3 over 2. I. And check the answer. Uh, tan pi over 6. Yep, we are correct. Next now, we want to solve this equation. I wonder how hard it'll be to solve. Or maybe I'll make some space. Don't think I'll need this answer. Well, let's just not remove it just yet in case it's useful. So that becomes root 3 minus I plus I root 3 z minus I squared z equals root 3 plus I minus I root 3 z minus I squared z. Well, they cancel, that's good. They cancel, that's good. So if I take that to the left, I'll get 2I root 3z. So I've accounted for that and that. And then if I take the I to the right, I get 2I. Oh, okay. The 2's and the i's cancel. So is z just equal to 1 over root 3? I guess so. I was expecting that to be a little tougher. Maybe I simplified it too much. Root 3 minus I plus I root 3z minus I squared z equals root 3 plus I minus I root 3z minus I squared z. No, looks okay. All right, B now. Z equals x plus iy. Indicate on the Argand diagram in the z plane the half plane k defined by z is x plus y more than 1. All right. That's 1. That's I. Minus 1 minus I. Okay, so we want the real and imaginary part to be more than 1. So for example, when y is 0, then you need x to be more than 1 when y is 0. So that's like here, x needs to be more than 1. And then for example, when, is that a modulus? No. When, let's say, x is 0, you need y to be more than 1, so you need to be here. So I think you'll get, maybe I should do a dotted to indicate it's not included here. Well, that isn't, yeah, you just, okay, I want to make this clear. Because it's open, I'll just put a circle here, dotted line here, and solid line here, solid line here. Okay, so that, I think that's it. That's certainly in the positive. What about in the negative? So like when x is minus 2, for example, y would have to be more than 3. So, oh yeah, so actually I can extend that out here. So, whoops, it's more like this then. Yeah. Yeah. So it's at this, yeah, it's at this 45-degree line. Has to be above it then. Okay. Next now, w equals 1 over I minus z. So w equals 1 over I minus z, and w is u plus iv. Express x and y in terms of u and v. Okay, so I'm going to simplify this. 1 over I minus x minus iy. That's 1 over minus x plus 1 minus yi. So that's I minus iy. I multiply by the conjugate. So then on the top, I get minus x plus y minus 1i. And then on the bottom, I'll get x squared plus 1 minus y squared. So that will be minus x over x squared plus 1 minus y squared plus y minus 1 over x squared plus 1 minus y squared I. And that's supposed to equal u plus I v. So therefore u is equal to minus x over x squared plus 1 minus y squared, and v is equal to y minus 1 over x squared plus 1 minus y squared. All right, now How difficult would this be to solve for x and y? How difficult would this be to solve for x and y? Okay, so I kind of realized just now that I made my life much harder by doing it this way around. Because I'm trying to have it the x and y equals u and v, it would have made a much more sense to make z the subject of the formula. So I just realized that now after thinking about it for a couple of minutes, that I've done this the awkward way. So I'll just remove all of this now. Apologies for that time wasting. And okay, let's have a look here. So I'll have I minus z equals 1 over w. So that means z equals I minus 1 over w. This will be better. So that's I minus 1 over u plus iv, which will be I minus u minus iv, and then I multiplied the bottom by the conjugate, that's u squared plus v squared. So that will equal all over u squared plus v squared, u squared I plus v squared I minus u plus iv. So that's minus u over u squared plus v squared plus, so that's the only real part, isn't it? So the imaginary parts would be u squared plus v squared plus v over u squared plus v squared I. And that's supposed to equal x plus iy. So therefore, we can see what the x is and the y is. So that's the x. So x equals that formula. And then that's the y. So y equals that formula. So I've written x and y in terms of u and v then. Okay, and now I want to apply this transformation here. So that is, I take a point, these points here, and apply this transformation. So where does the z get mapped to? So what will happen after you apply this transformation then? That's what I have to do next. I'm going to have to make some space, I think. Okay, so yeah, I'm gonna need some space. How can I delete this? X plus y is more than 1. Okay, so just remember that x plus y is more than 1. So if I add these two together, it should be more than 1. So that's u squared plus v squared plus v minus u over u squared plus v squared should be more than 1. Can I factorize? That'd be really nice. Could I? U squared plus v squared I minus u plus iv. So that's minus u squared plus v. Going to need to simplify this. Oh, these have to be positive, so I can cross multiply. U squared plus v squared plus v minus u is more than u squared plus v squared. Oh, fantastic. V has to be more than U. Okay, and just remember that U is the real one. So the imaginary component needs to be more than the real component. So if I put that in red, okay, so that would be like a 45-degree line where the imaginary is more than the real. So like I think it'd be like this. So all these Z points here, if that's I think they called that K, then this is the image of K over here. So that transformation looks like it does a flip over like that. Yeah. Okay. Okay. We don't see these questions anymore in the exam, so I'm a little bit rusty on them. So it makes me feel like maybe I should look at the previous question where I did this for the first time and see if I can improve on it. Anyways, there we go.